Assalamu alaikum students. I hope you all are doing well. Today's topic is scientific notation. As we are starting new chapter that is logarithms. So firstly we need to know about scientific notation and then we can move forward to that chapter. Okay, so let us see what is meant by scientific notation. The scientific notation the scientific notation help us to understand to represent the numbers which are very huge or very tiny in a simple form as multiplication of single digit numbers and 10 raised to the power of the respective exponent. The exponent is positive if the number is very large and it is negative if the number is very small. The general representation of scientific notation is this. Okay, so let me tell you about scientific notation, that what is scientific notation in clear cut way. Okay, so it is a notation or a method to write very large, very huge, or very tiny numbers in a simpler form. And what will be that form? The form will be single digit number multiplication of single digit number and 10 raised to the power. Means if you have a very large number like you can say 150 lakhs. Okay, this is very large number, or 150 crore, or millions, or billions, or trillions. So it will be a very large number. Or if you have very small number like 0.000000000 and many zeros and then 10, so this is very large, a very small number, a tiny number. So you need a simpler way to write this type of numbers, very large or very small numbers, for which writing you need to write so many digits, but you need a simpler way to write those numbers easily and quickly. So the scientific notation is that notation which you can use to write very huge or very tiny numbers, to represent them as a simpler notation, as a form of multiplication of single digit numbers and 10 raised to the power. Okay, this is the general representation of scientific notation. Like, this is single digit number, single digit number a multiply by multiplication of single digit number with 10 raised to the power, specific power. B is the power, 10 is the coefficient. B is power, 10 is coefficient. No, sorry, B is not coefficient. B is power and 10 is base. 10 is base and a is the coefficient here. Okay, so if you have very large number or very small number, you are going to write both of these numbers in this form. In scientific notation form means a single digit number multiplied with some base, that is 10, that will always be 10, 10 raised to power some exponent or power. Okay, okay, let us see further scientific notation rules, and then we will move forward to the example. Okay, so we have scientific notation rules here. To determine the exponent or power of 10, we must follow the rule listed below. These are the rules which we have to follow to write a number very large or a very small number in a scientific notation form. So the first rule is the base should be always 10. Base should be 10. The exponent must be a non-zero integer. That means it can be either positive or negative. Means 10 raised to power minus 2 can be there, 10 raised to power 20, or any negative or positive number, but it should be non-zero. It can't be 0. 10 raised to power 0 can't be there. Okay, the third rule is the absolute value of the coefficient is greater than or equal to 1, but it should be less than 10. So absolute value, if you take absolute value of any negative or positive number, it will give you the positive number and the same value. Like if you take the absolute value of minus 10, it will give you 10. If you take 20, it will give you 20. Okay, this is the absolute value. So they are saying that if the absolute value of the coefficient is greater than or equal to 1, but it should be less than 10. means it means that the coefficient, this a should always be a single digit number. A can always be a single digit number. Okay, it should be greater than or equal to 1 and less than 10, means the range of a is this one. The range of a is this. Let me clear the board and highlight the range. So the range is this is the range. A can be greater than or equal to 1 or and less than 10. Okay, no other possibility for coefficient a. And the last rule is coefficients can be positive or negative numbers, including whole and decimal numbers. Okay, this range is not in terms, it is not in terms of positive numbers, it is in terms of value actually. Like they can be single digit numbers, 1 to 9, 1 2 3 4 5 6 7 8 9. These 1 to 9 numbers can be in positive or negative, it doesn't matter, they can be positive or negative, but it should be, the digit should be 1 to 9. Okay, the range should be 1 to 9. Okay, now let us see the most important part, like how to write the power. Like how many places should the decimal point should move to write that in the form of scientific notation, to write the biggest number or tiniest number in scientific notation form. So the rule for that thing is, to write in scientific notation is, if the given number is multiple of 10, then the decimal point has to move to the left and the power of 10 will be positive. You will understand it by this example. They are saying if the given number is multiple of 10, like 5000. 5000 is the multiple of 10. How? It is 5 multiplied by 10, 1000, 5000. Okay, and this 1000 can be written in this form, 10 raised to power 3. Okay, so this is scientific notation form. This is the scientific notation form. Let me make it more clear for you by writing it here step by step. See students, if we have this value 5000, so that we have to suppose that decimal point is here at the last. By 5000, by seeing 5000 we know that it is the multiple of 10. Okay, so it is the positive number, so the power of the base 10 will be positive. How? We have to move this decimal point to the left, here, left, before the non-zero digit 5. When we will move it like this, 5.000, this point has moved, decimal point has moved here after 5. So we will write it in this form, 5.000 will be multiplied with 10 raised to power 3, because how many digits are there after decimal point? There are 3 digits. See, 1 2 3, 3 zeros are here. Okay, so after 5.000, we can write this here, this thing simply as 5, because this thing 0.000 will be represented by this 10 raised to power 3. Okay, so this is the scientific notation form of 5000. Okay, I hope you have got the idea of this example. Till here you have understood. Let us see the next example, which is for smaller number. If we have this number 0.0004, how we are going to write this number in scientific notation form? See, if the given number is smaller than 1, then the decimal point has to move to the right, so the power of 10 will be negative. Okay, for positive numbers or larger numbers, the power of the 10 will be positive and we will move the decimal point to the left. But for the negative for the smallest or tiny numbers, the power of 10 will be negative and we will move the decimal point to the right. Okay, this is right and this is left. Okay, let us see this example 0.004. Here 0.0004. So what we will do, this is a small number, okay, tiny number it is, so we will move this decimal point here to the right. We will move this decimal point to the right, so this will be written as 4 point, as before point 4 point and 0.000, because here this decimal point has moved to the right. So this is 0.0004 point. So how many digits are there? Sorry, here is an error here. It should be 10 raised to power minus 5. Okay. Okay. So if we have let us continue the example here. So we have written the 0.0004 in this form, 4 point, and there are how many zeros before this 4? 4 zeros, right? So before decimal point, this decimal point, how many digits are there? 1 2 3 4 5. So this will be written as 4 into 10 raised to power minus 5. Okay, this will be the scientific notation for this number. Let us see some more examples. There are some more examples here, like this one. This is for the larger number. There are how many digits in this number? 1 2 3 4 5 6 7 8 9, and here at the end we suppose that there is a decimal point, because for every largest number actually this was too much like large number, so we have decimal point at the end for the multiples of 10. So we are going to move this decimal point to this point after the one non-zero digit. So after 9, so 9.3, and how many zeros? 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. So what will be the scientific notation form for this number? 9.3 multiplied by 10 raised to power. See, after decimal point, this decimal point, how many digits are there? The 7 zeros and this 3, so 8 digits total. So this will be 9.3 into 10 raised to power 8. This is the answer. This is the scientific representation, scientific notation for this large number. Okay, so this was the first example. Now let us see the second example for the tiny number. The number is 0.00000017. This is very small number. So what we are going to do, we are going to shift this decimal point to this point after the first non-zero digit 1. So it will be written as 1.7. okay, sorry, this will be written as 0, and how many zeros more? 1 2 3 4 5 6 7. 1 2 3 4 5 6 7, and then 1, and then the shifted decimal point after 1, and then 7. this will be written as 1.7 multiplied by 10 raised to power minus what? Count these digits before the decimal point. This is 1 0 and then the 7 zeros and then this one, so 8. Okay, we will not count this 0. This will not be counted. Okay, this will not be counted, and we will count from here. 1 2 3 4 5 6 7 8. So 1.7 into 10 raised to power minus 8. Okay, so here I have found confusion. Sorry for the inconvenience. We saw this example here, this one 0.0004. When this will be shifted, when this point will be shifted after this 4.0, suppose, or we don't need to write it, 4 multiplied by 10 raised to power minus 4, it will be 4 raised to minus 4. Okay, will not be minus 5, it will be minus 4, because this 0 will not be counted, because from here we have moved the decimal point. So obviously from the position from where we have moved to the position where we have moved to, from and to, this range will be counted, this range of digits will be counted. So 1 2 3 3 zeros and this 4, 1 2 3 4, 4 digits are there before the decimal point which we have shifted here. So this will be 4 multiplied by 10 raised to power minus 4. Okay, let me admit my mistake and tell you people that I did it wrong, and now I have found how to calculate the scientific notation for the tiny numbers. So I have corrected my mistake here, and I have told you and made it clear that we are not going to count this 0. Sorry, this is same example here, that we are not going to count this 0 after we move this decimal point to this here, 1.7 multiplied by 10 to the power minus 8. Okay, let me give you one more example to make it clear, as it has been a confusion here. So let me give you one more example, like 0.00098. Okay, so what we are going to do, we are going to shift this point here, 9.8, and it will multiply 10 raised to power minus what? See, before point, decimal point, this is a decimal point here, how many digits are there? 1 2 3 4. This will not be counted, this will not be counted. So there are 4 digits, so 10 raised to minus 4. 9.8 into 10 raised to power minus 4 will be the answer for this question. Okay, so I hope you have got the point, and if you still have any confusion or query, you can ask me in the comment section and I will tell you. And if you need more examples for scientific notation, I will give you that as well. And in further videos I will solve some of the scientific notation problems to make it more clear. Okay, and if you like my content, my lectures, my videos, then kindly like it and subscribe to my channel and share with your friends so that they can subscribe as well. Thank you so much. Allah Hafiz.